Yeah. Hello everyone. Welcome to Tube 11 for circuit analysis for analog designers, and we are covering weak non-linearities, and how to solve them in this week. Let's start. Now, Tarpasa, you can tell if you have any specific doubts. You can ask.
Yes, sir. This week, 11th week, week 11, sir. I couldn't able to. How to find that V0 and V01 LT spice. Could you explain, sir, that one? For question number one, I'm able to get it, sir. I done perfectly.
This is the one, right? You can see my screen, right?
Sir, that.
Just okay. Wait a second. Wait a second. Can you see it now?
Yes, sir. Yes, sir.
Yeah.
The
So,
problem is sir, only one question explains, sir. That's it. I'm not able to get the logic, sir.
so this problem verifies the theory of current injection using simulations, and is intended to give you a sense of the numbers involved, how well the method performs. Use the weakly nonlinear RC filter in figure 2 to demonstrate the method. Use LT-Spice to set up the network. You should use arbitrary behavior control sources, element of LT-Spice. Okay, yeah, what is your issue in this?
Sir, first thing we need to, due to theory, sir, first we will find out the V01. With the
Yeah, correct.
V01, yeah, with the V01, we will short circuit for second order, we will short circuit that voltage source and we will substitute that value as a current source.
Uh, yeah, correct.
Correct for third order also or second order, and there will be independent term will be present, sir.
Yeah, one cross term and one independent term.
Yes, sir.
Yeah.
But I'm not able to find how to find out that V01, sir.
V01 is basic itself. Wait.
Here V0 is present. No, how to find that V01? I'm not getting. But that relation is there showing, no, sir, a separate plot V0 and V01.
Yeah, so V01 can be found out just by solving the differential equation of
First
this.
order.
Yeah, first order RC network is there. You can use Laplace for this. So you have input as sine 2 pi f1t, where f1 of 1 kilohertz is given to you, the capacitance is given to you, and the conductance is given to you. It will be a low pass filter. You calculate the frequency response of this, and with that, basically, since it's okay, I'll explain it on the tab. Just a minute.
Only one question, sir. But the rest of them I will do, sir. Don't talk. I know the concept, sir, but I'm not able to apply that, sir.
So this is what is given to you.
Yes, sir.
Just a So V01 you have to find in the following way. So
Yes, sir. Okay, after finding V01, we will find out with the help of the second order, we will find out the V02, sir.
Yeah.
Making some circuit, sir. How can we show that relation, sir? V0 minus V01 minus V02 in LT space, sir.
So in LT Spice, you can plot the spectrum. Okay. Here, what will happen due to this nonlinear terms? You will get V02 basically will contain the DC part and the second 2 kilohertz tone, right? So V02 will have what we will have in V02. It will have a term with Vi square, correct?
Yes, sir.
Yeah. So if there is a term with Vi square and you have Vi as sine 2 pi Fit. So what terms will you have in V02? You will have a DC term
Yes, sir. 1
and you
plus
will
cos 2 pi. Yeah.
Yeah, and you will have a term with Fi is 1 kilohertz. You will have a term with 2 kilohertz. Correct.
Yes, sir.
Then
Yes, sir. Yes.
V03 will contain Vi square, Vi and Vi cube. Okay, so this will have 1 kilohertz tone. Then it will have a DC tone. Then it will have a 2 kilohertz tone, and it will also have a 3 kilohertz tone. Okay, so
Mm.
whatever amplitude and phase you get for 2 kilohertz tone from in V02 and V03, you add them accordingly. For example, there is some A1 sine 2 pi 2 Fit. So 2 Fi because of squaring. You understand this? Plus some phi 1
Yeah.
plus
Yeah.
A2
A2 square.
sine 2 pi uh, 2 Fit plus phi 2. So you can add it accordingly, keeping in mind the phase. And so basically it will be A1 square plus A2 square plus 2A1 A2 cos phi 1 minus phi 2. Correct? The resultant amplitude of this both of them. So like this, you can you can find out what is the amplitude at DC, what is the amplitude at 1 kilohertz, and what is the amplitude at 2 kilohertz, and so on. And this you can find out first analytically through the current injection analysis method. And apart from that, you can use the LT Spice to that this circuit can be realized using arbitrary behavioral current controlled current source, and you can realize this circuit and see the spectrum of the output voltage by yourselves. And you can verify in this in the spectrum whatever magnitudes you have calculated for DC 1 kilohertz 2 kilohertz, those should match with what you get in simulation.
Sir, sir, could you please suggest me any problem reference books are exactly steps like SST, IIT control like that? Any channel is there, sir? For following the same steps, current injection method.
You can find some IEEE papers. I am not sure of any book as such for current injection.
Sir, if you don't mind, sir, sir, for a reference, could you please explain the one problem from the starting, sir? I will also participate in the discussion, sir.
Okay, so we can take one problem. Fine.
Yes, sir,
So
one problem, sir.
So I will find the analytical one, the simulation one. You can do it by yourself on the LT Spice. Okay.
Yes, sir. Sure, sir.
So, okay, we will consider this.
Sir, week 11 problem, sir. The problem.
Hmm? Yeah, weak nonlinearity. I understand.
Yes.
So consider this circuit. So we have so what we have over here is there is an input, there is a transconductor with and this is a weakly nonlinear transconductor, and this pushes in current to this parallel RC network, and let's say input is some 2 pi, input is some 1 kilohertz sine wave, and
Yeah.
the transconductor has a term of third order nonlinearity. So it basically the current output it gives as G1 Vi plus G3 VIQ. Okay,
Yes, sir.
and this goes to this parallel RC network, and you need to find out output voltage, like all V01 and output voltage is equal to V01 plus V02. So you need to find both of these terms. Sorry, here you won't find V02, you will find V03.
Yes,
Okay,
because of odd harmonics, no, sir.
yeah, because of our odd harmonics. So this problem we will be solving just 2 minutes. Okay, so first of all, we will assume that this network is completely linear. And if we assume so, what will happen is uh, here it will be G1, here it will be input. The current that is flowing is G1 times Vi, and it goes to this RC
It will.
network R
Yes, sir.
and C. And now we will find V01, right? So
Yes.
what is this? 1 by SC, and what we get over here is
Both are parallel. We can get. Yes, sir.
yeah.
R
So
into
it is R upon
1
1
plus
plus
RS is here.
SCR, correct,
Yes, sir.
into G1 Vi.
Yes, sir.
Okay,
Yes, sir. V01. Correct.
okay. So we can substitute values for this. So let's say R is equal to 1 kilo ohm, and C is equal to let's say 2 pi into let's say 1 picofarad, let's say 2 pi picofarad. So what is the 3 dB bandwidth of this network?
Sir, omega naught equal to 1 by RC, no, sir?
Yeah.
Yes, sir. Just a minute, sir. I will calculate it.
Wait, let it be 1 by 2 pi. So omega naught is equal to 1 by 10 to
RC.
the power 3 into
10 power minus
1
12.
by 2 pi into 10 to the power minus 12. So this is equal to 2 pi into 10 to the power 9. Correct?
Yes, sir.
So what is F naught? So this is radian per second.
2 by 2 pi will get cancelled, sir. 10 power minus 9. 1 megahertz.
So this is not
1
mega, this
megahertz.
is giga.
Yes, sir.
1 gigahertz. Okay, so let this be, let the input frequency be, let's say, some 100 megahertz. Okay, so now what will be V01? So V01 will be 1 upon 1 plus,
SRC.
you can replace S by j omega,
Yes, sir.
okay, or
Yeah, we will
j 2
write.
pi f for that matter. So it will be 1 plus j 2 pi f into RC. What is RC? We calculated, so this is 1 divided by 2 pi into 10 to the power 9, correct?
Yes, sir.
And so this will be, so its magnitude into, let's say Vi is some A sine 2 pi 100 into 10 to the power 6 t. So this is 100 megahertz. Okay, 2 pi f into A sine 2 pi into 100 into 10 to the power 6 t plus some phi. So the magnitude of this will get multiplied by A, and whatever phase it gives, it will come as phase of sine omega t. Is this correct? Do you understand this?
Yes, sir. But sir, the V01 relation, how it came, sir? That one
So
plus
V01, no, V01 is this is just a linear circuit, right? So V01 is basically whatever you get after solving this linear circuit. What input is a sine wave of 100 megahertz. Whatever you get, what do you get at output? There, it will also be a sine wave of 100 megahertz, right?
yes, sir.
Yeah, and what will be its amplitude?
So its amplitude will be that G1 by R plus I mean, it will get reduced, no, sir. Output.
Yeah, it will get reduced. It will basically get multiplied by the frequency magnitude response of this circuit.
Yes, sir. G1 R by 1 plus SRC.
Its magnitude, basically,
Yes, sir.
at S is equal to J 2 pi F, where F is the input frequency.
Yeah, yes, sir. Here the G1 R doesn't substitute, sir. That's why I get confused. Okay, okay.
Okay, okay, G1 R. Okay, so let's say G1 is 1 millisiemens in this example. Let's say G1 is 1 millisiemens.
Yes, sir.
Okay.
1 kilo can cancel 1 will be the answer, right?
Yeah, so it will be 1 over here, and
Yes, sir.
now you can substitute the values in this. So what do you get? 1 divided by 1 plus 100 into 10 to the power 6
Yes, sir.
divided by 10 to
2
the
pi.
power 9
Yeah.
whole
Got
square.
it.
2
Yes,
pi will get cancelled, no?
yes, yes, sir. Correct, sir.
It's a square root. So this will be the magnitude of V01.
Yes, sir.
Okay.
0.1, sir.
Now,
0.1 square. 10 power minus 2.
It will be basically point zero 0.01, right? Point
Yes,
1
sir.
square is 0.01. So 0.01 square root 0.01. What is its value? Can you calculate and tell?
Yes, sir. Just a minute, sir.
1 divided by 1 divided by square root of 1.01.
Yes. 1 point. Sir, it is approximately equal to 1 only, sir. 1.0049. Approximately equal to 1 only, sir.
Okay, so this you get. Now what you have to do, the second step is to ground the input. You will ground the input.
Sir, here small confusion, sir. Why we are grounding, sir?
Now it comes through the math, right? The now you are to V01. After that, what you have to solve? You will have to solve the second equation, which the you will have in order to find out the second term. what you will have to do is you will have to inject the non-linear current that will be formed due to this G3 Vi cube. Okay, so basically, what happens is I contains two terms. One is basically G1 Vi that you get from this linear transconductor that we have over here. Okay,
Yes,
so
sir.
assume this transconductor was linear. So basically, what we need over here, the current. Let's say what we need to find the total current that is flowing as the output. This you need to find. Okay,
Yes, sir.
so if you need to find the total current that is flowing through the output, what you will do is first of all you will remove this term completely and find only the linear component that is flowing into this. Okay, this will give you V01. Okay, the second term is you need to remove this term completely. Okay, and inject G3 Vi cube over here and see when this flows into this parallel RC network, you will get V03. Okay, so removing this term, what removing this term means? When will this term give zero current? When Vi will be zero, right?
Yes, sir. Yes, sir. Exactly.
Yeah. So that's why we ground the input while injecting the nonlinear current.
Okay.
So this was G1, and now you have to inject the current of G3 into Vi cube, correct?
Yes, sir.
That
Thought of.
is A cube and this goes into this RC network. So, what will be G3 into A cube?
Sir. Thought
So,
of.
and what will so basically what will Vi cube contain?
Okay.
So, it was A sine 2 pi ft,
A
correct?
whole cube, sir. Yes, sir.
So, on cubing this, you get A cube sine cube 2 pi ft, correct?
Yes, sir.
So, what terms will it contain?
Yeah, DC.
No, it
Yeah, sir.
won't contain DC.
Means a cube. Okay, okay, sorry. Yes, sir. No.
So,
Yeah, fine, fine. Yes, sir.
okay, what is the formula for this thing? So, we have sine 3 theta. How
Yes,
do
sir.
we write sine 3 theta?
I'll let
Sine
it.
theta plus 2 theta. So, this can be written as sine theta cos 2 theta plus cos theta sine 2 theta. Now, cos 2 theta can be written as 1 minus
Sine 2
2
theta.
sine square 2 sine square theta, correct?
Yes, sir.
Plus sine 2 theta can be written as 2
2 sine theta cos theta.
sine theta cos theta.
Cos square theta
So
will be
this is sine theta minus 2 sine cube theta
yes, sir.
plus 2
Cos
1
theta.
minus sine square theta
Yes, sir.
into sine theta. So this is 3 sine theta minus
4 sine
4
square.
sine cube theta. Okay.
Yes, sir.
So sine cube theta is sine 3 theta by 4 plus, sorry, wait. So this is equal to sine 3 theta So from here, sine cube theta can be written as 3 by 4 sine theta minus 1 by 4
Sine 3 theta.
sine 3 theta. Okay. So what does this term contain now?
Yeah, 3 by 4 sine theta, sine 3 theta. So, I mean, DC term will
So
be not present, sir. Only
G3,
1 kilohertz, 3 kilohertz.
G3 into,
Yeah.
yeah, G3 into 3 by 4
Sine theta,
sine
1 by
theta
1 by 4.
minus 1 by 4 sine 3 theta. Now this goes into
R into
this
C.
RC network, right?
Yes, sir.
And this will give you V03.
Hmm.
Do you understand it?
Yes, sir.
So now, how will you solve this? So
So
basically, this
what?
is a sine
Small load, sir.
2 pi
Sir, while
ft. Yeah.
sir, while we are substituting in LT spice, how can we substitute that value, sir?
No. You need not to do all this. This is for paper analysis. You don't need to do it in LT Spice. What you only need to do in LT Spice is you need to make this circuit using an arbitrary behavioral current controlled current source,
Operational
and
conductance happens like this.
yeah, yeah. So there are components that can give you square, like input square, input cube, all those terms that they can give you, right? So you can use them, and for example, and then basically create this transconductor, put it over here instead of the linear transconductor, and then simulate the circuit using a 100 megahertz tone. At output, whatever waveform you get, you take its Fourier transform and check the spectrum.
Okay.
So in the spectrum, you will have basically a fundamental tone and a third order tone.
Okay. Okay. Yes, sir. I'm new to this, sir. That's why I'm getting confused. Yes.
Are you able to understand what I'm saying?
Yes, sir. I'm able to, but that flow will not come, sir. Your practice now so much, sir. If I get a
No,
one
no.
time difference, that I can.
Okay, try to do it. If you are stuck at some point, you can mail me.
Yes, sir. Sir,
Okay.
sir, if you don't mind, can you repeat steps, sir, from step like in steps wise, sir? While recording, I will go through it once again, sir.
So the steps are first of all, you forget about the third order nonlinearity. Have G1 itself, calculate the transfer function, and since the input is a single tone, what you will get at the output, you will get the output's amplitude will basically be multiplied by input amplitude multiplied by the magnitude response of the transfer function. So you get V01 from there, and then the V01 you get over here as approximately equal to A. Then you ground the input. You basically, so if the input is grounded, this transconductor become useless. Then what you do is you inject the nonlinear current, that is G3 times the input cube. The input cube basically will, since it will become sine cube 2 pi ft, so that will contain both the fundamental tone as well as the third order harmonic. So what you can do after that is so basically you need to solve this circuit. So you have been you are injecting a current into this parallel RC network. You need to find out voltage, and this parallel RC network contains two frequencies. One is 2 pi ft, and other is 6 pi ft due to sine 3 theta term. So
Yes,
how
sir.
will you solve
Here,
this?
yes, sir. Here, while we are applying current source, we will find out V03, no, sir. We will apply a Laplace transform. We will get a V03.
So here you have to be careful. A Laplace transform only works for like if you have Laplace transform, it will work only like The magnitude response basically will give you magnitude response only for one particular frequency. So here you can use superposition because now the circuit is completely linear. First of all, you can calculate the magnitude response only due to the fundamental harmonic. So this will basically in that case you will replace S by J 2 pi F, and when you are calculating the magnitude response for the third harmonic, in that case you will replace you will forget about the fundamental harmonic. You will replace S by J 6 pi F. Okay, and
Yes, sir.
then find the
Yes,
magnitude
here frequency
response.
will get difference. That's why the capacitance values also will be very, no, sir.
The impedance value of the capacitance will vary. Correct.
Yes, yes, correct, correct. Yes, sir. Getting, yeah. And sir, here, okay, sir. While we are for LT spice, how can we get that, sir, thing?
So in LT Spice, you don't need that's what I said. In LT Spice, you just need to verify all the. So what you will calculate from here? You will calculate the overall overall magnitude of fundamental tone and overall magnitude of third harmonic tone.
Yes, sir. We'll
Okay.
find out V01 and V03, sir. This is the
Yeah.
total thing, right?
Yeah.
For
That's
first.
what I'm saying. Listen.
Hmm.
Listen.
Hmm.
That's what I'm saying. Once you have found out V01 and V03, V01 you have found out. What does V01 contains? V01 contains a tone at 2 pi f. Correct?
Yes, sir.
This will have some amplitude A. Okay.
Hmm.
What will V03 contain? V03 will contain a tone at 2 pi f and a tone at 6 pi f. Okay. Now this amplitude will be much smaller than this A amplitude. Correct?
Yes, sir. Exactly.
Because this has a cube g3 times a cube term, and this a will be chosen in such a way that you are in a weakly nonlinear region. So this term will be much smaller than a cube than this a term. So overall magnitude of fundamental frequency will be approximately equal to a. Correct?
Yes, sir. Yes, sir.
Yeah.
Sir, sir,
And
previous week, sir, small note, sir. Previous week, that non-linear term will come into picture at which time, sir? The Toda.
uh, sorry, I couldn't understand what you want to say.
Sir, we will find out, no, sir. We will say that third order will be insignificant, no, sir. That is compared to V01, V03 will be very less, no, sir. Even in the lectures also said, no, sir. I think
Yeah,
we
that
will.
will be it will be less, but when you that's what I'm saying. You plot that you make this circuit. Okay, you make this
Mm,
nonlinear circuit, and you make the nonlinearity using behavioral control sources,
mm,
and give a transient of 100 megahertz to this, and then calculate through transient analysis, check the output waveform, and you can do the Fourier transform of this output waveform. In Fourier transform, you will have both the tone at 1 kilohertz as well as 3 kilohertz.
yeah, the frequency spectrum. Yes, sir.
Yeah. So in those, the magnitude of these tones you have calculated already in V01 and V03. Correct?
Yes, sir. Yes, sir. Yes, sir.
Yeah. So what you need to do from LT Spice is you need to verify whether the calculated tones that you have of these calculated amplitudes that you have for these tones are are equal to the simulated ones or not.
Uh, yes, sir. Sir, small, sir. Okay, while we okay, sir, we'll substitute that, sir, for week 11, sir. While we're substituting that resistance value, how to substitute that value, sir?
Which value you are talking about?
Sir, yes, sir. In week 11,
Just a minute. Just a minute. Let me.
yes.
So yeah, what is the problem?
Yes, sir. While we are want to simulate in LT spice, no sir, we'll have data that VA is there, capacitance value is there, sir. We have G1 while we are substituting for A. How to substitute the resistor value in LT spice, sir?
So you get, so you make a resistor, you it asks for the value, no?
Yes, sir.
Yeah, so put that value.
Yes, sir. We have to substitute that G1 we is there, no sir.
1 by G1 will be the resistance, man.
Yes, sir. For first order.
G1 is the conductance. G1 is the conductance. 1 by G1 will be the resistance. And similarly, when you apply a behavioral current controlled current source across this, so what you basically have to do, you should use arbitrary behavioral current source element in LT spice. So if you use the arbitrary one, it will ask for like the second order, third order coefficients as well. So if you use a simple resistor, it will ask for only the resistance value, that will be 1 by G1. If you use the arbitrary one, it will ask for second order, third order coefficients as well. That
Hmm.
that you can
Okay.
substitute from like whatever is given in the question.
Okay, sir. While we are searching for resistor, we have to search for like that, so arbitrary resistor.
Wait. So so this is there, no, behavioral voltage and current sources. So see, arbitrary. So see, you can search for BI. You
Ah,
understand this? This BI will contain that. And what all values you can put in it. So here you can write the equation by yourself. Okay. So here what you have to write. So if you so here you have to write basically the relation between V1 and the current that this thing is pushing out, and this you will write in the following way. So you have I is equal to V in plus 2. For this for in this example, it has used V in plus 2. What you will have to do is you will have to make this a non-linear term. For example, V some alpha times V in plus some beta times V in square, and so on. And those values you will have to get from whatever are given in the question.
yes, sir. Instead of that resistor, we have to put that current source, sir.
Yeah, correct. So you can
Resistor
put a
will be
resistor.
absent now, sir.
No, no. The resistor you can put. Resistor's value will be 1 by G1, and in parallel to those, you can put these current source. Or you can, or okay, like other option is that put the resistor only. So basically, instead of connecting it to ground, like you won't connect it to ground. What you will do is you will connect it between input and output. Okay.
Yeah, there are series, no, sir. We have to connect the current source and series with the resistor and the
Yeah.
capacitor and voltage source,
Yeah.
right?
You have to connect it between the input and output. And what will be the current equation for this arbitrary element? I will be equal to difference of voltage between input and output.
Yes, sir.
G1 times difference of this voltage plus G2 times difference of this voltage square plus G3 times difference of this voltage whole cube, and
Q.
so on.
Yes, sir.
Okay. You instead of putting it to ground, you will have to connect it to the input.
Sir, we have to, G1 into entire thing, we have to substitute in equation form in that current source, right, sir?
Yeah, correct. Over
Yeah.
here.
R1 is for first order. What value we get?
1 by G1. 1
Yeah,
by
one.
G1. Yeah.
Yes, 1/G1 we have to substitute
No,
it.
no, you don't need to put. So you have to write the equation of I itself, right? What is I? I is G times V. So just G1 times V in minus V out plus G2 times V in minus V out whole square plus G3 times V in minus V out whole cube and so on.
Oh, okay. We don't need to substitute the value, sir. We according
You
to
need to substitute the value, man. If you don't substitute the value, how you will get the circuit working? Like
yes, sir.
every time in for every run A, B, C, you need to take the values that is given in the question, and instead of G1, G2, G3, you have to put those values.
Ah, yes, sir. Sir, according to that, it will calculate. We don't need to substitute that V in minus V in V out. No, sir.
No, V in minus V out, it will calculate. V in
Ah,
that you have to substitute in this parametric form. This is basically this is a function that calculates the voltage at that particular node. V bracket uh, V is the function, and the argument you give is the node's name, net name. Here it has called it IN, capital IN, and the output node it has called as output. So what you will do is I is equal to V bracket capital IN minus V bracket output. Now it depends on whatever node name you give.
yes, sir. Yes, sir. Okay, got it. Sir, while we substituting, okay, sir, according to the values, it will get V0. How, sir, while we plotting, how to get V01, V02, sir?
While plotting, you won't get V01, V02. While plotting, you will just plot the output waveform, and the output waveform will basically give you, you take the FFT of output waveform. In that, uh, you will have the magnitudes of first harmonic, second harmonic, and third harmonic. You just need to verify the magnitudes with whatever you have calculated analytically using current injection.
Okay, okay. Yes, yes. Okay, okay. Means in LT space we don't get that V01 analytically we will find out and we'll verify it, sir.
Yeah, analytically you will find out V01, V02, V03. What will these terms contain? These terms will contain magnitudes of first, second, third harmonic and DC. So whatever first, second, third harmonic and DC you get from analytical calculation of current injection, you need to verify it by taking the Fourier transform of the transient analysis in LT Spice.
Yes, sir.
Okay.
Yes, sir. I mean, show V0 when is V01. I am thinking, sir, how to get that one in LT space. I spend more than 10 hours, sir. That's why I'm asking, sir.
Okay.
I didn't get an idea how to substitute that V0 minus V01T. Sir, question number one is direct question only, no, sir, from the lectures.
Hmm?
Question one is a direct question only, no, sir.
Figure 1 shows a weakly nonlinear amplifier. It is excited by uh, two closely spaced input tone, A1 and A2 determine amplitude. Yeah, it is basically trigonometry, man.
Yeah, nothing more. Suspense or no, nothing, sir.
No.
Yes, sir. Fine. Good. Okay, sir. Sir, week 12, there is only one question, sir, because and that's why I'm thinking, sir.
Hmm?
Week 12, only one question, sir. This is the last assignment.
Yeah, week 12, what you have to, just a minute. So, in week 12, you can see my screen, right?
Yes, sir.
In this one, what is there? Figure shows a weakly nonlinear second order Butterworth filter. realized using transconductor and capacitor techniques. Choose capacitance C so that 3 dB bandwidth is 1 megahertz. Vi sine 2 pi ft. Use the method of current injection to calculate the amplitude of third harmonic at the output. Plot it as a function of frequency. So, like earlier, f was given as some particular frequency, but now you have to calculate everything in parametric form. And once you calculate it as a function of f, you can use MATLAB to plot whatever analytical equation you get for the third harmonic.
Yes, sir.
You use MATLAB to plot that like third harmonic strength, and one graph you generate from MATLAB and other graph you generate from LT-Spice. In LT-Spice, what you do is you run transient analysis for various input tones of starting from 10 kilohertz to 1.51 megahertz in 100 kilohertz steps. You run like transient analysis for each of them. You calculate the third harmonic strength for each of them and plot it on a separate graph. And you need to compare the graph of LT-Spice and MATLAB.
Without MATLAB, we can't do, sir.
Without MATLAB, how you will find out the any like if you use Octave or any of the plotting uh, application that you can use to plot basically like whatever you find analytically, you need to plot it, right?
Yes, sir.
So you need to use some uh, this thing.
Yes, sir. Previously, for I think week 3 or week 4, you thought MATLAB, no, sir, that Butterworth, I think you, sir, I don't know, only, sir, but. Sir, can you please give some reference, sir, how to MATLAB that and I will go through it, sir, in internet or anything. That's so
The
how.
MATLAB, you can type whatever documentation you need. So MATLAB, do you have MATLAB with you?
No, sir. Actually, I have at the time. I think week 4 or week 5. You said no, sir. I have my friend's laptop in that light, right, sir?
So, like you can use online MATLAB. You can see how to get an ID and like use MATLAB online. Apart from that, there is an extensive documentation. Whatever you need to find, you can or you can YouTube. You will get some basic tutorials on MATLAB to start off with codes and all. And after that, you can use it to plot various waveforms.
Yes, sir. For our question means what are the things I need to substitute, sir? That will I will follow, sir. Because time is very less now, sir.
Sorry, I couldn't get your question. I couldn't understand what you want to ask.
Yeah, yes, sir. For third order harmonics to get the output means what are all sufficient to know what are the things I need to substitute.
You need to make the circuit in LT-Spice and run the transient. That's all.
Okay. For MATLAB, sir.
For MATLAB, okay, if you let me see. So simulate the filter in LT-Spice. Uh, like Plot the amplitude of the third harmonic on the same plot. So, like you get one plot from MATLAB, you get other plot from LT-Spice, and you can you can get the data from LT-Spice, and the data that you get from LT-Spice, you can import it to MATLAB and plot the analytical one that you calculated, calculated and put it in MATLAB. That you can plot with the data of LT-Spice that you have on the same plot, and that will be done. Or if you are facing trouble in that, what you can do is you can just plot the third harmonic from the LT-Spice, and you can mark some points with hand calculation on that same LT-Spice plot, and show that for the particular frequencies that you hand calculated, your LT spice data and hand calculated data is matching. That also you can do.
Oh yes, sir. That will be fine, sir, for me. Sir, that is operational transconductance only, no, sir.
Yeah, so you will have to use the same thing, same the behavioral current source in that case.
Yes, sir. Fine. Yes, sir. The behavioral current source is perfect, perfect, sir. Sir, here that bubble is there, no, sir. That is a negative, no, sir.
Yeah, that is to denote that current is being sucked into the transconductor.
No, sir. While we are typing transconductor, operational transconductor amplifier,
No,
we
no,
will
you
get.
don't need to use operational transconductor. You need to use that BI thing.
Sorry, sir.
You only need to use that BI thing, that behavioral current source that we saw right now, no, for the
Yes.
week 11. So you need to use that BI thing, and you need to write in the equation for uh, the current to voltage relation, and that in its parameter.
Okay, okay. Okay, we need to write the current source and in parallel with in series with the resistor and the current source like that, sir.
Here there is no resistor, man. Here you just
The
need to,
capacitor, sir.
for example, yeah, yeah, correct, yeah.
The current source and capacitor and current source, sir.
Yeah,
Questions.
uh,
It's too while seeing it very complex, sir. Internet also nothing is available, sir. The subject. Yeah.
so
That's
this
why.
is like that's what. So now it's straightforward, right? You just need to do the week 11's assignment. You have done the week 11's assignment, is it?
Yes, sir. Yes, sir. I have done, sir. First question number one perfectly done, sir. Question number two, I get lot of confusion, sir. I couldn't, but I what and all I have done, sir. But couldn't. While after the listening class, I understand what mistakes I have done.
Okay.
Sir, could you please give some more hints, sir? This week is the last week. I have to get good scores, sir. That's why, sir.
No, that's what. What more hint can I give you? You are just to use you are to use that behavioral current sources to make this transconductor, plug in
Hmm.
the circuit, and run transient analysis. That's it.
Yes, I mean, there are three trans conductors are there, no? Four conductors are there,
Four.
no? Four current sources we have to put, sir. That
Yeah, correct.
okay, okay. That's why, sir. I mean, is there any twist or like that? I'm thinking. Okay.
No, the same, like it's straightforward only. It just requires some amount of work. That's it.
Yes, sir.
Okay.
Yes.
Any other doubt?
Uh, Nothing, sir. Sir, for final exam, could you give any strategies, sir?
Uh, what strategy can I like? Okay, just go through all the assignment once. The
Mm.
question will be more or less similar to what you have done in the assignments.
Yes, sir. Week one, week two, I have done, sir. Now I'm done, sir. Week three, only, sir. I think that S parameters is there, no, sir.
Ah,
Question. Week number.
okay, yeah, you can. So basically, that's what you need to go through all the assignments, and the solutions are also now at least the final answers are provided on it. You can solve it and verify the final answers, and yeah, you can prepare for the exam.
Yes, a final paper will be evaluated by professor or by TA, sir. How
I
many
don't
members?
know, man. All those logistics, why do you care? Just prepare for the exam, give the exam, and be done with it.
Okay, okay, sir.
Okay, so